Hello friends, good afternoon and welcome to the EduSite Network. Our topic of discussion today is production function, which is part of our series on microeconomics, and we have with us in our studio our subject expert to steer this very series and lecture. Let me introduce him to you, Dr. Rajiv Shukla, PhD coordinator at the Indian Institute of Foreign Trade, New Delhi. And with this introduction, I welcome sir. Thank you so much sir for coming, and I request you to begin our today's lecture.
Thank you. Hello friends. In previous lecture, we had discussed about some market structure. We have covered all the phases of market structure, including perfect competition, monopoly, monopolistic competition, and imperfect competition, or you can say the oligopoly. Now, today we are going to start one more important feature of microeconomics, is it production function. We covered about the indifference curve analysis, where we have seen about the phases of indifference curve analysis, about the properties of indifference curve analysis, where we approached the two goods, or you can say two commodity, and after get the two combination of two commodity, then we get some utility. The same, all the features, all the concept are present in the form of iso product curve also, but in comparison to or either to commodity, we can discuss about the inputs, either labor and capital, and we discuss in terms of utility, but in here iso product curve we will discuss about the output. After get the approach of input in the form of labor and capital, then we get a output. So let us begin with the production function. First, I would like to mention what is the meaning of product function, or you can say a production. So production function, as you seen, production refers to the transform of input of resources into output of goods and services. Everybody knows about the production when we approach some of the units of labor or some of the units of, or the both two variables, either the labor and the capital of the some unit, to approach and to get some output in the result of this approach. So production refers to the transformation of input or resources, whatever we applied, into output of goods and services. In other words, production refers to all of the activities involved in the production of goods and services. There are so much many activities. Either if you cannot consider about the input variable, either you cannot consider about the approach, whatever you applied in the form of labor or capital, exclude there are some certain activities which is also in the form of production. What is called from borrowing to set up or expand production facilities, to hiring workers, purchasing raw materials, running quality control, cost accounting, and so on. So rather than referring merely to the physical transformation of input into output of goods and services. So both the factors are included under the production function, either the physical transformation or in the form of some types of purchasing raw material, running quality control, accounting, hiring workers, production facilities. So all the things when we approach to make up a particular or the distinguished thing, then we get it in the form of output. So here simply mean what is the production? Production refers to the transformation of input, whatever we applied, or resources, whatever we applied, into output of goods and services. Now, for example, suppose a computer company hires worker to use machinery, parts and raw materials. So in factories to produce personal computers. This is also part of production, as we discussed in previous slides. The production functions also include from borrowing to set up or expand production facilities to hiring workers. Here you can see in an example, a computer company hire workers to use machinery, parts and raw material, and factories to produce personal computers. I think everybody knows about this fact that we have a five factors of production, which is a very necessary. So in this phase, you can see over there the output of a firm can either be a final commodity or an intermediate good, such as computer or the semiconductor. Suppose you can say whatever the final output comes after we approach some labor and some capital on a particular output, then we can say now this is the final output and this is called a production. No, either the final output form in the form whatever you get, or either to the intermediary goods. Whatever we applied in the form of input labor or the capital or the production facility or the hiring workers, whatever we used and whatever you get, either the full you can get a full final output, or either you can get a intermediate product. This is also a part of production. So, the output can also be service rather than a good, such as education, medicine, banking, etc. So, we are not in confusion that we only get a output in the form of goods. Rather, if we get a service, or if we get this type of example, suppose education, medicine, banking, this is also a part of production. So, here you can I think you may be a clear criteria about the production function. What is the meaning of production, which is not only include of goods also, this is which is also include a services part also. So, if we approach some types of input, either in the form of labor, either in the form of capital, either in the form of purchasing of hire worker, either in the form of production facilities, this is also a part of production. And whatever you get, either you get a final output or either you get a intermediate good, this is also a part of production. So, here you can see what is the meaning of production function. Now, we approach how can we draw of production function over figure. So, here you look, a production function refers the functional relationship under the given technology between physical rate and input, physical rate of input and output of a firm per unit of time. Here you can see over diagram, say in the x-axis we can take a labor input, in the y-axis we have weekly production. When you increase the production, when you input the more and more labor, the production exceed from is the upward scenario. So, here this figure is also called a system fixer's production function. So, here you can approach or you can exceed the input, then you get a more output. So, this is a production function figure, where a production function refers the functional relationship under the given technology between physical rates of input and output of a firm per unit of time. Now, types of production function. In the short run and the long run, we all of are aware about the short run. We have a very limited period of time, and the long run we have a time to expand our production capabilities, our infrastructure. But in a short run, we have a very limited or the short period of time. So, here you can see types of production function. Short run production, one variable constant, either you can approach or you can exceed or you can increase only a one variable, either you can increase a capital or either you can increase a labor. We have a two variable here, one is labor and one is capital, and both are necessary to produce or to get a output. We all know about this fact. Work in tandem with laws of variable portions. When we constant one variable, then what we get in the form of three stages. One is increasing returns, second one is diminishing returns, and the third one is negative return. We will discuss further all the three stages in describe mode for further slide. But in the long run production, both variable can be exceed or can be increase or can be fluctuate. So, works in tandem with laws of returns to scale. The same the three forms are also be present under the long run: increasing returns to scale, constant returns to scale, and the third one is diminishing returns to scale. Here you can see in the short run there is not a single constant returns to scale, but in the long run there is certainty of constant returns to scale. So, now production function with two variable inputs. What I said, when we are going to take a iso product curve, which is a quite similar, which we discussed earlier, indifference curve. In indifference curve, we have taken two commodity or you can say in indifference curve we talked about the two commodity and utility. But in iso product curve we are going to talking about the two two factor of production, either you can say a labor and capital, and talked about the output. All the things are quite be similar in comparison to indifference curve analysis. The difference of the indifference curve and the iso product curve is, in indifference curve we have taken two commodity and utility, and in the iso product curve we are going to take a two factor of production, labor and capital, and we talked about a output scenario. So when two factor are taken as variable factor which are substitute for each other, here I would like mention why we use a substitute word, because if you are constant one variable, then you can exceed another variable. If you constant a labor technique, then you can exceed more capital inputs. Either you can constant a capital, then you can exceed a labor force. So one variable constant under short run, and both variable are fluctuate, or you can increase or decrease as per your convenience in long run. So when two factors are taken as variable factors as which are substitute for each other, this technique is known as isoquants or the iso product curve, which are similar to indifference curve techniques of the theory of consumption. So what are the iso product curve, or what are isoquants, is also called a iso product curve. Here an isoquants may be defined as a curve representing various combination of two inputs. Two inputs means either labor and capital. So isoquants may be defined as a curve representing various combination of two inputs that produce the same level of output. If you recall the indifference curve analysis, an indifference curve may be defined as a curve representing various combination of two commodity. Here we are talking about two inputs that produce the same level of output. In earlier, if you recall the indifference curve analysis, where the indifference curve said indifference curve may be defined as a curve representing various combination of two commodity that produce the same level of utility. So here you can see an isoquants may be defined. This is the difference of indifference curve between and iso product curve. So an isoquants may be defined as a curve representing various combination of two input that produce the same level of output. An isoquant is also known as iso product curve or an equal product curve or production indifference curve. On an indifference curve shows the same level of satisfaction to the consumer, which we have seen earlier in our previous lecture. Similarly, every point on isoquant would indicate the same amount of output. This is a very important feature. Every point on isoquant would indicate the same output level. Either you can choose a combination, B combination, C combination. All the combinations have a same output scenario. An isoquant may be defined as a curve which shows the different combination of the two input producing the same level of output. If you can put a labor, suppose 10 labor and 20% capital, and then you get 100 output. This is a combination of A. Suppose when you reduce the labor 5 and 10 to 5, and you increase the capital intensive from 20 to 25. So now you get a same output on the B combination. So this is the reason where the isoquants may be defined as a curve which shows a different combination. So combination is differ. Now you can use a 5L plus 20 capital, in economics we denote a K. So 25K plus 5L, and now you get 100. In earlier combination you get the same level of output with the 10L plus 20K. So that's why if you change the proportion of the particular input or the labor input, then you have to change the second one input criteria accordingly. Because if you not change, then the production, then the output whatever you get is quite different from the earlier one, which is not justifiable according to this law. So iso product curve may be defined as a curve which shows the different combination of the two input producing the same level of output. Here you can say, with the help of some schedule, we can draw a table, and it would be helpful to know the what I mean to say. Isoquant schedule. Here you can see a combination A, B, C, D, E. Units of labor 1, 2, 3, 4, 5. Units of capital 12, 8, 5, 3, 2. The law said that there is not a single differentiation between any combination if you get a differentiate output. If you get a differentiate output, then the laws is not in proper format. So, whether if you change the units of labor or the capital, accordingly you change the another unit of the another source to get the amount of output same. Suppose a combination, when you use 1 unit of labor, then you use 12 unit of capital, then you get 100 output in units. But in a B combination, you can you change or you can increase the unit of labor from 1 to 2. So, you have to decrease the another unit of capital as the proportion where you get the same output. So, with the level of the output to be same, you have to interdepend, or you have to balance of both the commodity or both the input or the factor of production accordingly, where the output may to be a same manner. When you choose the C combination, 3 units of labor, then the units of capital is 5. To maintain the level of output, you have to focus what are the decrease of the concerned side and what are the increase of the another side. So, you have to maintain a output level be same. So, here is schedule, whatever but the definition said, that isoquant curve, a curve who shows the different combination with the same level of output. So, here isoquant schedule have different combination A, B, C, D, E with the same output level 100. Either you can choose A, B, C, any combination, and any combination gives a same level of output. Now, the same we have seen over figure also. Now, here you look, isoquant curve, units of capital, here units of labor. You can see is the 1 unit of labor is the 12 unit of capital, then you get a combination. Then the labor exceed the capital decrease, the unit of capital decrease from 12 to 8, then you get a B combination. When you choose a C combination with 3 units of labor and the 6 units of capital, and when you choose a fourth one is the fourth one unit of labor, 4 unit of labor, then you choose a D combination. Here this is a very important thing, that either you can choose A, B, C, D, E, the level of output is same, because जो आपने कमी करी है एक तरफ एक यूनिट में और दूसरी यूनिट में बढ़ाया है, वो सिर्फ इसके लिए है कि आपका जो आउटपुट लेवल है should not be changed. So, here you can either choose A, either B, either C, either D, or any one point or the combination on the curve. If you can say the same curve, if the curve is changed, suppose if we draw another curve, either the below or the upside of the concerned figure, suppose if we draw here another curve and we have another point over this curve, then we can say the concerned point maybe get a higher output in terms of below one. Sir, but on the same curve, if have any combination either on A, B, C, D, O, B, they will get the or they will give the same output level. So, here is isoquant curve which represent a different combination with same level of output. Now, isoquant map, if you recall, the same thing is indifference map. An isoquant map is a set of isoquants representing different level of output. Now, we are talking about the so many maps or the so many curves. Here we are talking about, talking the only one curve. Only one curve here is. You can denote IQ1 suppose. Now we are talking about the some other curves which represent in a single figure. An isoquant map is a set of isoquants representing different level of output. Here you can mention very carefully a different level of output, not different level of combination. The different level of combination we have seen in earlier figure. Now we are talking about the different level of output. If we are talking about the different level of output, then definitely we have a several graph or several curve, or you can say several isoquant curves, because we know on the same on the single curve we have a same amount of output. Either we can choose A, B, C, D or any combination on the single curve. But if we are talking about the different level of output, that it clearly means that we have a set of isoquants curves. So a higher isoquants indicate higher level of output. Here you can see over figure we have a IQ1, IQ2 and IQ3. Here you can see, suppose if anyone asks which one curve gets more output in terms of another curve. So you clearly answer the curve which is a quite higher in comparison to two others gets or will give the maximum output in comparison to previous one. Here IQ1, IQ2 or IQ3. So which one curve is more placed on top, which is called IQ3. So IQ3 curve will give the more output in comparison to previous one. Here I would like recall again one point. We at the definition of isoquant, what the iso product curve definition said, if you have combination of a single curve, if you have suppose if you have a 4 combination on a single curve, every combination give a same amount of output. When the curve change, or if you have any combination of another curve, then the output level may be different, or the curve which is a quite on top from the previous one, that one curve will give a maximum output. So here IQ3 will give the maximum output. So this is called isoquant map, where we can consider a highest one graph will get the maximum or will give the maximum output. An isoquant map, as I said, is a set of isoquants representing different levels of output. A higher isoquant indicates higher level of output. So the figure of the isoquant map and the topic of isoquant is also very important for competitive exam also. There are 2 or 3 questions may be asked in economics related exam. So isoquant map is also a very important feature of microeconomics. So an isoquant map is a set of isoquant representing different levels of output. A higher isoquant indicates higher level of output. Each combination on the same isoquant gives the same level of output, which we discussed. However, a higher isoquant represent higher level of output. जितना ऊंचाई पे ग्राफ होगा, जितना ऊंचाई पे कर्व होगा, वो सबसे ज़्यादा आपको आउटपुट देगा. Now, types of isoquant. How many types of isoquant? Isoquant may be different shapes depending on the degree of elasticity, of substantiality of inputs. First one is linear isoquant, second one is input-output isoquant, third one is kinkered isoquant, or the fourth one is smooth convex isoquant. So first one, we will take a first one, what is the meaning of linear isoquant and how the concern perform degree according to the degree of elasticity. Here linear isoquant, here you can say a left one downward slope, 3 lines, and which the y-axis is natural gas, the axis is diesel, and the electric power you can get in the form of output. This type of isoquants assumes perfect substitutability between different factors of production. Thus, for example, a given output, say 100 units, may be produced by using only a labor capital. The type of isoquant assumes perfect substitutability between different factors of production. So, the shape of such isoquant shall as on the left side. If you can see, a linear isoquant is the shape of the isoquant is the left side. When we talk about the input-output isoquants, this type of isoquant assumes perfect complementary or the zero substitutability between the inputs. Here you can see when there is only one method of production for any product, its isoquant is of a right angle shape. Here you can see isoquant figure is a right angle shape, and in the x-axis we can take units of labor and the y-axis units of capital, but this type of isoquant assume perfect complementary or the zero substitutability. And when there is only one method of production for any product, its isoquant is of a right angle shaped. Here you can see a right angle shape. This type of isoquant is also known as a Leontief isoquant. Sometimes the question may be asked in the form, what is the meaning of Leontief isoquant, where you can answer of this question, this type of isoquant assumes perfect complementary or the zero substitutability between the inputs. Perfect complementary. Smooth convex isoquant. The fourth one feature of the smooth convex, and when it happens, it assumes continuous substitutability of labor and capital only over a certain range beyond which factor cannot be substituted for each other. So, it assumes continuous substitutability, either the one side fluctuate or the other side fluctuate. So, this is the isoquant appears as a smooth curve convex to origin. You can identify the curve of the isoquant which clearly emerge. It assumes as the heading suggests, it assumes continuous substitutability of labor and capital. The figure clearly emerges. Suppose if you can take this one unit of labor and this one unit of capital, when you can suppose you assume there is not a figure, suppose there is not a figure, there is no a single figure, and when we assume a simple line graph and we draw a line from here to here there, then we can see some amount of labor and some amount of capital. Sometimes we decrease the unit of capital and we increase the labor unit of labor. Now we again suppose some decrease of the unit of labor, then we suddenly increase of the some unit of labor. Now we draw a figure, then the figure shape may be in this form, which clearly emerges. It assumes continuous substitutability of labor and capital. When you increase of another factor of production, then you can decrease of the another factor of production simultaneously. So, this isoquant appears as a smooth curve convex to origin. Now, you looked about the decrease or of the concerned another capital. Suppose if I increase the labor input, then we have to decrease in another labor of production, either you can say a capital form, we have to decrease of the unit of capital to make the output same. What is the meaning of the marginal rate of technical substitution? You can see whatever we left, whatever unit we left from the concerned capital, from the concerned labor of factor, from the factor of production, this is the rate of the decreasing of the concerned capital or the labor of factor of production. This is called of marginal rate of technical substitution. जितनी दर से आप substitute कर रहे हैं, what is the rate of substitute? From one side you increase and the second side you decrease. So, what is the rate between them? So, this is called of marginal rate of technical substitution. So, the principle of marginal rate of technical substitution is based on the production function. where two factors can be substituted in variable proportion in such a way as to produce a constant level of output. जिस दर से, suppose if you increase units of labor, then you have to decrease a unit of capital. And what is the rate of the increase or the decrease? So what is the rate? This is the rate called marginal rate of technical substitution. So the principle of the marginal rate of technical substitution is based on the production function, where two factors can be substituted in variable proportion in such a way as to produce a constant level of output. So if you can make the level of output be constant, then you have to increase one factor of production and then you have to decrease another factor of production in a such a way. And what is the way called, or what is the rate called, is called the marginal rate of technical substitution. So marginal rate of technical substitution indicates the rate at which factor can be substituted at the marginal without any change in the level of output. All the figures, all the tables suggested that that there is a rate where you can change a variable proportion of another unit of the concerned factor of production to other. So what is the rate? This is the rate what you have to increase in another in one factor of production, and whatever you decrease or you can left a second one factor of production. So this is a rate called a marginal rate of technical substitution. So here you can see, for example, the marginal rate of technical substitution of labor for capital is the number of unit of capital which can be replaced by one unit of labor without changing the level of output. Now if you can, if anybody asks what is the rate of marginal rate of technical substitution for labor, suppose anyone can ask what is the MRT rate of labor. So what is the answer of this question? The marginal rate of technical substitution of labor for capital is the number of units. Suppose if you increase from unit of labor from 1 to 3. Now you can suppose if you recall the first one table where you put 1 unit of labor and 12 unit of capital, and you get 100 unit of output. In the second combination, you increase a 1 unit of labor from 1 to 2 and you decrease from 12 to 8 capital to make the output level of constant. So here what is the marginal rate of technical substitution for labor, which is the number which you left when you increase a 1 unit of additional labor. So what is the number? From 12 minus 8, and the marginal rate of technical substitution for labor, it is 4. कि जिस दर से आप एक तरफ बढ़ा रहे हैं और दूसरा यूनिट को एक तरफ कम कर रहे हैं, what is the rate, what is the number of units? So this is the number of unit which is 4. So now you can say the marginal rate of technical substitution for labor is called 4 unit. So here the marginal rate of technical substitution of labor for capital is the number of unit of capital which can be replaced by 1 unit of labor with the changing level of output, without the changing level of output. Now the concept of marginal technical substitution can be easily understood from the table given below, or here marginal rate of technical substitution. Here you can look a factor combination A, B, C, D, E, we have a 5 combination. Now you can see a unit of labor 1, 2, 3, 4, 5. What I said, unit of capital, and we here take marginal rate of technical substitution for of labor for capital. Suppose we get a same level of output from the all combination which is 100 unit. When you put a unit labor 1 and 12 unit of capital, then you get suppose 100 units. Now if you exceed a labor unit of labor from 1 to 2, then you have to decrease some unit of capital from 12 to 8. What is the marginal rate of substitution? Is 4:1. जितनी exceed के बाद जितना आपने another unit capital में जितने numbers कम किए हैं, this is called a rate of marginal rate of technical substitution, which is 4:1. Now If we go on if we go on C combination, then we can see a unit of labor is 3 unit, but we have some left unit from the capital side. Now the marginal rate of substitution from 8 to 5 आए हैं. Now the marginal rate of substitution is 3:1. जैसे जैसे आप एक एक यूनिट बढ़ा रहे हैं, आप कैपिटल में कुछ यूनिट्स कम करते जा रहे हैं. कितना कम कर रहे हैं, कितने रेशियो से कम कर रहे हैं, विच इज कॉल्ड मार्जिनल रेट ऑफ टेक्निकल सब्स्टिट्यूशन ऑफ लेबर फॉर कैपिटल, एंड विच इज विल clearly emerge from, if you look at the combination, then the labor units of labor is 4 and the unit of capital is 3, is a 2:1, and until unless is the last one combination E. When you look unit of labor 5, then the unit of capital 3, from 3 to 2. Now the marginal rate of technical substitution is 1:1. So here is marginal rate of technical substitution. It will seen from the previous table that the marginal rate of technical substitution shows a decline, is always be in a manner of decline. ये आप कह सकते हैं कि वो घटते हुए आपको दिखाई देती है. In factor combination EGB, 4 unit of capital can be replaced by 1 unit of labor without change in output, which clearly emerge in the previous table. Now, so 4:1 is the marginal rate of technical substitution at this stage. In factor combination C, 3 units of capital I can be replaced by 1 unit of labor without any loss of output, and such the marginal rate of technical substitution 3:1, and similarly the marginal rate of technical substitution for combination D and E is 2:1 and 1:1 respectively. So what is the formula of the marginal rate of technical substitution, which is labor unit upon capital units. In an isoquants curve, if you can see the marginal rate of technical substitution, if we can draw over a figure, then we put the same in figure also. Here you can see a small movement downward, the isoquant curve from A to B. In the figure given below, say by K is a substitute by an amount of labor without any loss of output, the slope of the isoquant curve from Q1 at point A therefore equal to K. Here you can see, if you look this figure is also immersed in the same concept of marginal rate of technical substitution. When we choose A, now we can choose B. Here you can see, when you choose B, there are additional unit from 1 to 2, but here you can reduce or you can decrease the unit of Y from 12 to 8. So this is the portion, this is the area you can say is the marginal rate of technical substitution, or what is the rate, you can see what where the number of unit reduce to make the constant level of output, which is called a 4 unit. The same manner is continuous from up to 0 and up to 5/5 unit of labor, or the up to E combination. So this is the representative figure for the marginal rate of technical substitution. The marginal rate of technical substitution is equal to the ratio of marginal product of two factors. Suppose, since the definition, output remains the same as an isoquant curve, the loss in physical output from a small reduction in units of capital will be equal to the gain in physical output from increase in the unit of labor. Here you can see a figure in the isoquants map form, where you can see the first one figure gets more output in comparison to previous one. So thus the loss in output is equal to the marginal physical product of capital multiplied by the amount of reduction in capital. So likewise, the gain in output is equal to the marginal physical product of labor multiplied by increase in labor. So the same, here you can see a capital or the labor कि जो चीज जैसे जैसे आप बढ़ाते जाएंगे, suppose as I said earlier, let's assume there is not a figure, there is no a single figure, then we can draw, or either you can draw over this figure, you can draw a line over this figure, whatever the concept suggests, you can clearly know about this fact. The concept said the loss in output is equal to the marginal physical product of capital multiplied by the amount of reduction in capital. Likewise, the gain in output, suppose if you increase the capital, now the labor is also, unit of labor is also increased, and you get a maximum output because from the previous one curve. When we talked about the third one curve, where the capital comes in the form of, आपने increase किया capital in the form of third one curve, now you can see the capital here and the labor, unit of labor is also increased. When the both the variable are increased, then you definitely get the more output or the maximum output or the output from the different output from the previous one. So, here the gain in output is equal to the marginal physical product of labor multiplied by the increase in labor. Why the marginal rate of technical substitution diminishes? क्यों घटती है? Why the marginal rate of technical substitution diminishes? It will seen from the above table and diagram that the marginal rate of technical substitution diminishes, and this is one important feature. In other words, a silent characteristic of the marginal rate of technical substitute is that it diminishes as more and more units of labor are substitute for capital. कि जैसे जैसे आप एक units को substitute करेंगे another unit से, then the marginal rate of substitution diminishes. Thus, as the quantity of labor used in increase and the quantity of a capital employed decrease. So, the unit of capital that are required to be substituted by an additional unit of labor diminishes, and this is known as the principle of diminishing marginal rate of technical substitute. So, what is the concept? What is the principle of diminishing marginal rate of concept? The unit of capital that are required to be substituted by an additional unit of labor diminishes. As a more and more unit of labor are used to compensate for the loss of the unit of the capital to maintain the same level of output. The question may be arise in also some exam also, ki why the question is begins from this line, why the marginal rate of technical substitution diminishes. So, to make the level of output be constant, the unit of capital that are required to be substituted by an additional unit of labor diminishes. This is known as the principle of diminishing marginal rate of technical substitution. Now, if you can see why the marginal rate of technical substitutes diminishes as a labor substitute for capital, and it means the isoquant must be a convex to the origin at every point. This the concern, if you can see it, the isoquant must be a convex because of this. If the marginal rate of technical substitution diminishes, then the isoquant curve must be convex. It happens accordingly if you increase one particular factor of production and you decrease one another factor of production, either you can decrease the capital, then the figure draw which will be in the form of convex. So, the isoquant curve must be a convex to the origin at every point. Now, we discuss about the properties of isoquants. If you recall the properties of indifference curve, the quite similar properties of the isoquants curve, where we can what is the difference? Difference is only we are talking about the factor of production or the labor and capital, and we are talking about in terms of output, either the utility or either the satisfaction. So, an isoquant curve like an indifference curve is a downward sloping curve towards the right. We have seen just now a higher isoquants represent the larger output. We discuss no two isoquants can intersect each other. No quants are convex to, isoquants are convex to origin, and in between two isoquant there may be a number of isoquants, and units of output shown on isoquant are purely arbitrary. So, these are the properties. We can take a first one. An isoquant curve, like an indifference curve, is a downward sloping curve towards the right. That means it has a negative slope. We have seen in a previous slide, in a previous to previous slide, that this is a convex shape. So, if the convex shape, which is clearly emerged, it has a negative slope. That implies that if more of one factor is used, less of other factor is needed for producing the same output, which clearly emerges. If anyone can say that this is the figure of convex size, which clearly emerges that if more of one factor is used, less of the other factor is needed for producing the same output. Thus, when the quantity of say labor is increased, the quantity of other factor say capital must be reduced, so as to keep the output constant on a given isoquant curve. If the downward slope, if we can talk about the downward slope of isoquant follows from a valid assumptions that the marginal physical product of factor are positive, this is the use of additional unit of factors give positive increments in output. And so, when one factor is increased yielding positive marginal products, the other factor must be reduced. We talked about so many times, if the level of output be constant, then you have to increase in one factor, then you have to focus, or then you have to decrease in another factor to make the level of outputs be same. So, it would be interesting to note that if so isoquant do not have a negative slope, certain logistic aversities would follow. And thus, for example, if the isoquant slope upwards to the right, if you draw the concerned curve from upwards to right, then you can clearly know about this fact why the isoquant curve is not in properly formed in upward direction, where the combination as the definition suggests, every combination gives a same level of output. When you draw a isoquant curve in upward direction, then you can find that the production may be then the production or the output on different level of combination may be differ. So, which is not a justable thing. So, this means that in spite of having used more units of both labor and capital, the total output remains the same, which is just not possible if the curve in the upward form, not in convex form. You can see over there what we discussed. If in this diagram factor combination T on the isoquant curve shows more unit of both labor and capital, therefore, it will give more output at combination P where less unit of labor and capital are used. Here you can draw what I said. If you can draw upward figure or the upward isoquant, why we say that this is not a justable thing? Why we say? Because we know on the combination of the suppose any combination of the figure on the curve of isoquant gives a same level of output. But if you can draw this type of figure of isoquant, then you can see on the combination of P, where you put a unit, suppose a unit of labor and the B unit of capital, then you get a satisfaction of 100 unit. When you see a combination of T, where you increase the capital from B to C, and you also increase a labor unit from A to D, which is not a justable thing as per the definition suggests. And if you increase in both factor of production, then you may definitely get the more production in comparison to previous one combination. And the law suggests, or the definition suggests, that every combination gives the same level of output. So, if you want a combination of T may give a same level of output whatever you achieved on P, then you have to decrease one factor production. Either if you can increase a capital from B to C, then you have to be decreased from the labor A to D to maintain the same level of output. So what I want to convey that the isoquant curve is always in a convex form. It not be possible to upward. If you make it possible, then you find a different level of output on a same combination, on a same curve combination, which is not a justifiable. So as such, point B and T on the isoquant curve cannot indicate equal product. As said earlier, every point on isoquant curve shows the same level of output, and upward sloping isoquant curve cannot indicate the same level of output. That is why the isoquant curve is always in a convex form. Likewise, suppose isoquant of labor is combined with more unit of capital or less unit of capital. In case of isoquant, cannot be a constant product curve. The another thing, if you can look isoquant curve in a perpendicular shape, then you can ask, is it possible? No, is it not possible? You look, suppose that the this isoquant curve in this form, then you look, a capital OC, labor OA, the production get on P point, suppose 100. One, from the T combination, you increase the capital unit from C to B, but you have not changed single change in labor unit. So definitely, if you increase one factor of production or the capital unit of capital, but in the other hand the another variable is constant, then definitely the another combination of which is T give a more output. If you want to make a level of output to be same, then you have to decrease a unit of labor, because you have already increased the unit of capital, but the labor of unit is constant. So definitely you can get a more output on T combination, which is not a justable thing as per the definition of isoquant suggested. Now similarly, the horizontal phase, if you look the horizontal form of isoquant curve, which is also not adjustable because of the change in level of output on combination P and T. You can see over there, if you make the horizontal line of isoquant curve, then you can see where the capital unit of capital is constant and the labor the unit of capital then the unit of labor is exceed, and one of the factor of production is constant. So if you look the P combination, whatever you get output on P, which is differ from the combination of T, and the law suggests that every combination gives the same level of output on isoquant curve. So here you can see when you increase a labor of unit of labor, but the capital unit of capital is constant, then the output level may be a different on second one combination. So this is why the isoquant curve therefore cannot be equal product curve. From the above discussion, it would be clear that isoquant curve must slope downwards to right. The higher isoquant represent larger output. We discussed about this fact, is higher isoquant greater the output and vice versa. You look in the diagram, the combination of T on isoquant curve shows larger output 200 units and the point P on isoquant curve 100 units. So thus the combination of OA capital and the OB labor produces 100 unit of output, while OC unit of capital and OD units of labor produce 200 units. So as such, IQI, which lies above, is the IQ2, the right represents a larger level of output. So, so it clearly emerges if you look IQ1 curve and the IQ2 curve, where you can see the level of output which is a little bit different, or the combination of T is will give a higher level of output. So here you can see why the higher isoquant represent a larger output. We know about this fact that the combination on the same curve will give a same level of output. Now if the curve change, then the higher curve will give the more output. Here you can see over figure the T level of combination on IQ 1 give the 200 units of output in comparison to previous one. Now, two isoquant cannot intersect each other. If you look over a figure where the isoquant curve intersect on P point. So, the level of on the P is also on as well as IQ1 and as well on IQ2. So, if two isoquant intersect of touch each other, this means that there will be a common point on the two curve as shown in the diagram. So, this implies that the same factor combination which is not justifiable as the definition suggested. So, this is a quite absurd because the same factor combination cannot produce two different of output. So, this is not possible the same combination on the both curve which produce the same level of output. We know about this fact that the two combination or the 3 or the 4 combination on the same curve of isoquant will give a same level of output. If the curve change, then we can say the higher curve or the higher or the combination on the higher curve will give the more output in comparison to the previous one. So, here are the why the isoquant are convex to the origin, why the isoquant two isoquant curve cannot intersect each other, why the isoquant curve is convex to the from the origin. These are the properties of isoquant curve or isoproduct curve which we have discussed now. Now, this is a isoquant and the isoproduct curve functions which we discussed today. In coming lecture, we are going to talk about the features of the returns to scale and how it works. We are also disclose some of the fact of welfare economics. We are also looking some of the facts of the concerned pricing strategy under microeconomic series. So, today we are going to sum up of this lecture with all the properties of the isoquant curve. Here you can see what is the difference. You can look over there indifference curve and isoquant, which I said that in indifference curve we have talked about the commodities and the satisfaction, and isoquant curve we just talked about the production and the output level and the factor of production which we used in a labor or the capital form. Thank you very much.
Thank you so much, sir, for this very descriptive analysis and also for telling our viewers what we are going to be doing in the future and what has already been covered today. So, that has already been summed up. So, with this we bring our lecture to a close by thanking sir for being here. Thank you so much, sir. And viewers, thank you for watching us and following us. Thank you and have a great day.